Hello everybody, Thy Lord Root here, and welcome back to another episode of Flight for Survival. So you may wonder why it's so far in the future. And in fact, I've recorded about an hour and a half of footage that I intended to speed up for this episode, but long story short, I've been putting up a satellite constellation because we now have RemoteTech. Now in the process of that, the open broadcaster did something pretty nasty to the video card and then it crashed, so we lost all that footage because MP4 is not recoverable in that manner. However, instead of doing it all over again, I've decided, we'll leave it up there and it'll provide us more room to do other things we want to do. So in addition to RemoteTech, we've also got a couple of things here. We have a mod called Station Science that you could see adds in really cool things like plant growth experiments for space stations. And what we're going to have to do with that is we are essentially going to want to send these guys up on specialized ships, maybe something kind of like Progress, and bring them down. I'm not going to do it just quite yet, but it's something to think about because we've also got another thing here as well. We have several contracts that I accepted in the interim, one of which includes exploring Minmus. Now, we'll do some of these contracts, and I might even get one or two here. Of course, Rodviz is still in orbit because our rescue mechanism is basically computer-based or whatever. We may have to change that at some point, but what we'll do is we'll explore all these places. We've got an ion engine that we can test that'll yield us 135 science, so I'm going to do that at some point. And that's actually not that hard of a thing to test, although it's well, we don't need the ion propulsion though. We just need to get up to this range, which may be difficult, but we have about a year to do it. We also have the main cell, which we can test shortly. This is orbiting the moon. We have about 2 years to do that, so we may test that. We've also got a request to test at LFB KR12, whatever that is. Landed at Kerbin and also this stack decoupler. So we got a lot of things to test, a lot of science to get. And we will get these things going, but let's return to this third satellite in our constellation here that unfortunately we've missed out on, because that is where we are focused now. So the basic idea is that we're going to put these guys up into an equilateral triangle around each other, and I've now got communication through my other two satellites. I'm just going to go ahead and burn out here. The basic idea here, and this is kind of why it's taken so long in the first place, is because, believe it or not, these orbits are kind of sensitive. They may not be as sensitive as I'm thinking they are, but I've been doing a lot of fine-tuning on them just to get them about where they need to go. And where they need to go precisely is 2,000,000 863,000 meters, give or take. So I'm in the process right now of getting these guys set up. And we may in fact lag behind. We are a little bit high there. And now we're a little bit low. But I will get that set up really quick. And unfortunately we missed something with RemoteTech that... Oh, come on. There we go. We missed something with RemoteTech that we would otherwise, you know, whoa. That's kind of irritating. I think what's happening is this thing is maybe getting moved. If we can just get that centered. Not rotated, that... There we go. We get that rotated, then what we can do here is we can... Whoa, okay, yeah, this is part of the issue with using the mouse wheel. But basically, that's about our orbit we want, give or take. And we've got this issue, because you may notice that there are lines going to other satellites in orbit, and that's basically our connection indicators. So what we want to do here is, before we lose connection, we want to first of all point to the node. And then we will also want to schedule it with exec. Now these things actually ship with a fair amount of delta V. I believe it's close to 2400. And I've gotten a little bit better with FAR. I've learned how to get a suboptimal gravity turn. And on occasion I actually get a fairly good one. This one was actually good, but unfortunately, because the video got corrupt, you know, we missed it. However, yeah, there we go. And this thing will automatically slow us down, but I'm gonna, when I get close by, I'm just gonna give it a chance to orient itself real quick, because otherwise it may lose alignment. But yeah, watch that. It's doing that burn automatically for us. Now we are unfortunately a bit ahead, and what we want to do is fall behind a little bit. And so this is the part where it can get really tricky really quickly. We're going to use this remaining delta V to get us to where our angle, like, we want this to be about 30 degrees. or thereabout. Let's point prograde and get that going. This doesn't get our... Whoa, okay. Let's go retro. I'm gonna limit the thrust on this. I've been doing this on my other ones to make it a little bit easier to maneuver. I'm gonna limit the thrust on these just a bit. Now we're a bit inclined, so I need to take care of that too. And I think we can do that in this one. There we go, that's good enough for me. Just one maneuver here. I'm gonna raise this up a bit, not too much, because we don't want to fall too far behind. Maybe like 100 meters or so. But with that having been said, we will point to our orbital vector, or not our orbital vector, our node vector here. And we will get everything going, because I believe we are set up otherwise. We just need to fall behind a bit. And in fact, I need to schedule that. Although I could technically schedule it at any time now because we have a connection. But this is the part that can take several days, is getting these guys aligned. And I was questioning whether it's worth doing that or not. And the answer appears to be yes. If we don't do that, then what will happen is that we will... There we go. And we're a bit better off than we were. What will essentially happen is that our relay network that I'm going to deploy will have gaps in it. So we need to get line of sight for these guys, and this is about where we slow down. But you'll see, after a little while, well, maybe, I don't know if this one is properly set up. And in fact, I'm going to change something real quick. I'm going to rename this vessel to Commie Mark 1-3. That's been my naming convention so far. If we switch to this sky real quick, I've already got this one set up to talk to, or the other one set up to talk to one of the CommieSats. But when we do that, now we have ourselves a connection. And we have ourselves an isosceles triangle. It's good to have an equilateral triangle if we can. Because as you can see, this... We basically want to stretch this out. And in fact, what I'm going to do This is about to be stretched out to the point it needs to be. I'm just gonna do this. I believe that's going to be good enough. I'm not entirely certain of that, but that appears to be okay. Both, basically, these complementary, the sum of these angles needs to be, somewhere to the tune of 60 degrees. And if we draw, like, this angle up here needs to be about 120 as a result. You can see we've already spent about 6 days correcting that. There we go. And something tells me I'm not on periapsis like I want to be. There we go, we are almost there. That is really about as good as I can ask for. And just in time, too. This is a bit more scaling than I would like, but with that having been said, I think it'll be okay for now. And so the basic idea with our relay sats is that we're going to put them in a high enough orbit to where the distance between any of these satellites and anything in orbit will be more or less. Okay, we lowered our orbit a bit. I'm going to point retrograde really quickly and correct that, but we want that basically to be about halfway, because this is just outside the range of the omnidirectional antennae. And in fact, this is so important not to screw up that I'm going to point prograde, and I'm going to give myself about a good minute to make sure that I'm about where I need to be. But yeah, I mean, that's more or less the deal with these things. it should slow me down automatically. So, we just need to raise our periapsis a small amount. I think if I'm at 10 seconds, I should get that. And maybe not. Now I've raised my apoapsis a little bit too much. Again, these orbits are quite fine-tuned. And I don't really trust RemoteTech's flight computer to get this right. In fact, I'm going to turn down the thrust on this even more. 12.5 seems like a nice number for us. And give us some time to... What we need to do, we need to point prograde. I mean, our eccentricity is going to be really, really, really low on this, and again, I am being a little bit on the paranoid side. But I do happen to want this to turn out to be quite circular in the end. And we need time to make adjustments too. So, we'll get down to 10 seconds or so, and we will there we go. I believe that eccentricity is enough. We won't be deviating from that really for quite some time. We'll just have to see if we do need to adjust one. I believe this one is the Commie 3 will be the one we will need to adjust. But we will do that later. For now, let's go back to the Space Center and deploy Commie Jr. Commie Jr. is our series of relay satellites, and we will probably end up doing 2 of them. And so what I'm going to do is I'm going to put these about halfway. These guys will have about 4 or so omnidirectional antennas. The geostationary satellites have 2 on them. But what we can do here is I waited for that inclination to stabilize, and now it won't wobble as much. I will turn on fine control, and you'll notice this time I didn't rotate the vessel. I mean, I could have, but I found a way to keep the inclination under control. So what we'll do is around 60 meters per second or so. I'm not going to pitch over to 5 degrees immediately. I'm just going to slowly tease out that prograde vector. So we will want to deal with our inclination some. And maybe by like 100 or so. Would like to deal with this, but you can see like I need to figure out which way our inclination is changing. So I'm going to go ahead and do that now. We don't want this stuff to smash into the ground because it is expensive equipment. I believe I'm going up, so I will begin pushing this down. The hope is that we will basically hit 45 degrees and around. Maybe like 1300 or so. I need to push this in a little bit more. And of course, when I demonstrate it, it doesn't work out the way I want it to. Unfortunately, we are a little bit steep. We should probably fix that. Like I said, it's better to be steep than to shallow because if you are too shallow, then as we've seen, definitely too shallow, so we're going to lose a lot of we're going to lose a lot of delta V on this. However, that'll be okay. I mean, we can pull this guy down, and I guess in this case, I mean, we have so much delta V on that second stage, we almost have 3,000. It really doesn't matter as much. We just want to, in this case, if we cannot get the perfect gravity turn, we should correct our inclination. In fact, this was quite... okay, yeah, we are now off. But we're in the upper atmosphere, so I'm just going to get ourselves going. We just need more in the way of And in this case, we still have plenty of delta V. Going to dump all of this stage into getting our periapsis height as low as we can, or rather as high as we can, because that of course is in the ground. You can see we have this connection delay up there, and that delay goes up to infinity when, you know, we're not connected. One thing I do want to do real quick is hit my action group so we can get connected to something. And I'm pretty close as it is. I'm gonna get us out to roughly where we need to be. Which I believe is something a little bit like that. So what I've got to do now is I have to schedule this into the future somehow. So we're going to point at the node and exec, and it'll be touch and go for a bit. I mean, we've got a very narrow sort of deal going on. Very narrow window. As you can see, like, once we get over this horizon, which will happen fairly soon, we will lose that signal. And these guys are a little bit too far out for our Communicatron 16, which have an effective range of 2.5 million meters. There's about 300,000 meters that we cannot reach because of that. But, when we get out there, you'll notice we'll begin to get a connection. Really, I want to get a connection from all of them. I believe at this range, there is no satellite I cannot reach. But I'm just going to get that ready. And unlike the other ones, these don't really have to be perfect. The other ones, I mean, they don't really have to be perfect either. But they're more sensitive because part of the reality here is that these guys are, you know, they'll move around and change positions if we're not careful. And the worst case scenario is one of these guys is not going to be able to see the whatchamacallit, the KSC, which is our only real way of talking to our probes. But with that having been said, nonetheless, I do want to get this to as circular of an orbit as I can. I mean, as we come out here, you'll notice we got a connection almost instantly. Oh, what was I doing here? I was raising that periapsis. Okay, so let's zoom out. While I want this, while I did say there was some leeway here, I don't really want to be too wasteful here. I think that was 1421 is our apoapsis. 1431 will do, and then we will, we can even afford, I believe, an inclination change would be a good, or maybe not. Let's not change inclination yet. I mean, I think that would be a good place to do it. And we'll schedule that burn, and we have plenty of Delta V left, largely because we don't have to go anywhere. But yeah, that one, oh, I see what happened here. We should get a connection with that one if we're close enough by. And what we may do with this is, because there is some sensitivity in this, we may launch eventually 4 or 5 of these. But one of the things that is rather nice is that as long as we're in comms range, don't do that. Oh, yeah. I guess I've got to... Actually, we will do the node here. You know what, 1421 is fine. Let's just do a test orbit and see if... Okay, so there is going to be a brief moment where these guys will lose communication. There's really only a couple of things we can do about that. The first is, We might decrease our orbital period on this. I'm not sure if I want to do that. I mean, getting 100% coverage is going to be asking for a lot. And you see, the problem is that if we look at, like, if we set this guy as our target, distance is greater here. And this guy will need to be pushed back, no doubt. Because if we set him as a target, his distance is too great too. I mean, these guys are essentially where they are. Because if we don't put them there, then we won't be able to patch the gaps here. What was it I was doing? Oh yeah, I need to go normal. In fact, I need to definitely go a little bit normal here. And we'll make that inclination change happen. It won't take much. And we managed to do some fairly strange things here. I mean, the more we can push Commie 3 back, you know, the more okay, go retrograde. Oh wait, no, go prograde. We're at apoapsis. There we go. That is pretty good. That's going to suit us for some time to come. We just need one more satellite here, and we will be ready to deploy a special treat. Maybe not so special for anybody who's used it. But special enough to me. I mean, I think really as long as we can get this guy taken care of, then there's really no cause to complain. These guys don't have to be perfect, they just have to be there. So we are about ready. And we'll try to get something a little bit better out of this. This is something we're going to have to worry about, by the way, whenever we go to other planets, or even other moons. Because you can't shoot radio through a planet, it'll absorb it. best way of approaching this. Probably first and foremost, turning off SAS would be good. They say not to use it, but I found that it's very difficult not to sometimes. Unfortunately, we've got these oscillations that we've got to get under control. Once we get far enough out of the atmosphere, we will. I mean, this is a fairly effective launch stack I've found. The other one, the one I used to launch the satellites, the polar satellites, they are a little bit on the difficult side to use. About where we need to be. It's actually not a bad launch profile. As long as we can keep that time to Appalachians up, we will be absolutely fine. And really, if we can just get out of the atmosphere, I'm not going to complain. In fact, it probably is time for us to begin completing our gravity turn, because at this point, so fast in such a short amount of time. I mean, we don't have to contend with the atmosphere anymore, we might as well. In fact, I'm just going to go ahead and raise our collapses to the proper area. There's your periapsis to Colorado. How much time do we have on this thing? I guess I shouldn't be dilly-dallying like this. Let's see, 14, 12. There we go. We'll just, well, fine. There we go. I guess I need to click on this guy. What was it, 1420? Or something to that effect. No connection. I'm hoping we will get one soon. If not, yeah, we got one through the relay sat. Fortunately. See, that relay sat is already helping us, and that's something I can't complain about. Our inclination isn't bad either. Since we have a connection on the relay set, let's see. Yeah, we'll do that. Having that connection, it does mean some good things for us. Okay, go to node. That's what I thought it was doing, to be honest. There we go. We'll can this guy right now. Okay, they were about in the same period, although if we do that, then it is possible that we will have full coverage. We may need 3 relay sats for full coverage. But what I'm gonna do, I mean, these guys don't have to be connected to each other as such. They just have to more or less be at the right place at the right time. There we go. Where is this other guy? I mean, the idea is to make it statistically likely that somebody will be able to see a relay stat. Okay, can I not place a maneuver because there's no connection? That is really bizarre, to be honest. There we go. What I'm gonna do now is I'm just going to fine-tune that orbit. Over time, these guys may get a little ahead of each other. Because I don't know the exact... I mean, it's actually not bad, to be honest. I mean, it's... We will do that, though. But the more satellites we launch, the more strongly connected this network will be. So I'm just going to, at the moment, get this guy ready for his burn. I think at some point a third relay sat will be in order, but I don't, I'm really not going to do that. There we go. Periapsis is what? We will just trim that very slightly. In fact, we'll trim that here. Oh, both of these guys. We'll go retrograde real quick. Both of these guys have a signal. That's promising. Okay, go retrograde. Retrograde. Okay, now go prograde. Let's see. Oh, can I run a test? Oh, I want to run a test. Running a test may be a bad idea. I'm not sure if I want to do that. But we're... Yeah, that's circular. only thing left to do now is correct inclination, which probably isn't all that big of a deal. We could do that right now, actually. There we go. And now for the great test. That test will come, I guess really we need to rename these. I'm going to name this 1-2, and this guy will be named 1-1. So rename vessel 1-1. Okay, now what we'll do is we will get the ScanSat going, and then we may return to manned spaceflight. It's been a couple of months. I'm sure Jeb is a little bit bothered by the fact that he hasn't been able to go to space because of RemoteTech. But in this case, we've got a map satellite. And what do you do with a map satellite? Oh yeah, there was one other thing I forgot to mention too, by the way. Johnser is supposed to be dead. I tried deleting him and it turned him back into an asteroid. Go figure. Oh, but yeah, anyway, the question is, what do you do with the map satellite? Well, a map satellite needs to be polar, right? Because with the polar satellite, you can essentially get these guys mapping every square inch of the planet, or virtually, anyway. I mean, we do have this still to deal with here. Yeah. That inclination deal is not very useful here because believe it or not, because we're going in a polar orbit, we want that to be 90. Need to be really fantastically careful. You can see our time to apoapsis is probably will drop here in a bit. Yeah, it's dropping because we're fighting the inclination change so much. Which kinda sucks. This is expensive hardware. But basically what's going to happen is that with deadly re-entry, this thing will heat up. maintain this for long enough, we'll be able to get out of the atmosphere, maybe. I'm somewhat doubtful of that. But yeah, this thing's beginning to heat up. That spells disaster for us, because we have no way to really get out of it. Our engines will, yeah, we will overheat shortly. There's really nothing we can do at this point, because we're going so fast. That's what happens if you go too low. I wasn't really trying to demonstrate that, but yeah, we lost. I'm not quite sure what we lost. Probably our probes. I'm sure it'll tell us when this thing crashes. I'm surprised more hasn't heated up, to tell you the truth, because we have quite a bit of heating going on here. I bet you we lost our probe body, because I can't really control anything. And even if I could, I have no connection. Although there is this weird glitch. It's one of the reasons I have not done a rescue mission yet, is occasionally I'll just randomly lose connection even though I should have one. Like there, for instance. I'm not sure if it's that I'm getting a little bit too far over the horizon. No, I mean, in that case, I bet you it was probably because my whip antenna. Let's bring up far. What's the flight situation is hardly nominal. What's the yeah, we're heating up a fair amount here. And our fairings will go pretty soon because our dynamic pressure is building up. In fact, that fairing is about to be toast, I reckon. And in case you were wondering what happens with deadly re-entry, if we could ever reach that temperature, and it already happened, I mean, this thing is essentially an arrow. It's not got a ton of drag, so pressure is likely to continue building until this thing heats up and explodes. It's the engine temperature. These things probably have some amount of tolerance, although I'm surprised, honestly, that G's didn't get us. G's may be what got our antenna, but... See, max G's are somewhere around here. Max... There was a deal with the maximum G-force here that they used to show it. They don't really show it anymore. But we are way, 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 way above terminal velocity. You can see we should not be... We're going Mach 4 or thereabout in the atmosphere. I'd like to say I think we could survive this, but I don't really think it's the case. We're hitting the ground at Mach 3. Well, there's your rods from God. So what happened? Okay, so we lost our whip whip antenna. And that caused us to lose our connection. I don't know if there's a replacement for it eventually, but it would be nice to have a better whip antenna. One that, could reach further. Not that we particularly need it. I mean, it'll be fine without it, but we'll close far now. Are we stable? Part of this, I'm sure, is due to the planet's rotation. I'm not going to go for such a steep descent this time. I'm just going to be thankful that decent heading. I mean, if we can get above 30, because I mean, we will have to expend a lot of Delta V just to do plane correction. I'm beginning to, I'm hoping that if we just leave it like this, that we can do something to correct it. But I don't want to lower. Oh, there we go. There begins the descent into madness. We've entered too low again. I can only hope that we don't lose too much in the way of efficiency here, because we're now beginning this sort of worrying trend to where I guess at least we can begin now to correct our inclinations. Oh, no, 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 go back, go back. No, okay, yeah, there's not much we can do here except... what just happened? I guess as far as far is concerned, we're still in the atmosphere. Well, there's that, and there's the fact that we're severely unbalanced. Which I consider to be a bit of a problem. Because there's really no way for us to get out of this, so I'll spare you. I guess. Oh, because we're in the atmosphere, we can't leave. I'm just gonna reset it. That'll be fine. These polar flights are a lot more difficult to do. And I don't believe I'll let this thing stabilize. Although we are actually doing pretty well. That is steep enough to do. heading of our prograde vector. Yes, you take your sweet time. Okay, we'll have about 10 degrees of inclination to correct, it would seem. I'm just going to leave it there until we get out of the atmosphere. Because as long as we're gaining time to apoapsis, then it really does not matter to me. We can easily correct 10 degrees of inclination if we can prevent ourselves from flipping out, which is what killed us in the first place. Oh, and the good thing is we are going to be in space soon, so this may actually be something I can easily correct. SAS now without impunity. I'm going to use that to adjust my inclination some. Okay, you know what? We have done well for ourselves. I'm not going to allow this stuff to break just yet. But I will turn on SAS for now and try to get things under control. There we go. We're 250 is about where we want to be. We got, I believe, 3 degrees of inclination to correct. But we have a connection over here too, so that's very good. That means that we will be able to put this in. Now, as a, well, maybe not as a precaution actually, that is pretty good. Where is the moon? We'll get that sorted out real quick. At least get ourselves into orbit. Now, I don't know if these things can act as a relay. Um, if they've only got one antenna. My guess is probably not. Can we do anything to correct this guy here while we're at it? I mean, we got plenty of Delta V, we might as well. Even though this raises us up quite a bit. Probably better to circularize, though. Well, we'll get that circularization going. And correct some of this. But while we're at it, we have plenty of electricity. So why don't we put it to good use? Or we already did. We can actually open up this map by going up here. This is... We're too low right now to really get good data out. Or this should turn... I believe it'll turn... Maybe, Oh. You know, I'm not sure what color it turns whenever we're high enough. Because we are apparently high enough. I don't know why it's blinking like that. Maybe that just means we're the active one. Nonetheless, being high up is good. Because it means we can... this is sort of... in many ways, against, Oh, there we go. We still have our descending node. Now this inclination, we got it down pretty well. Let's make it go down some more. How does it affect our apses? See, not too badly. If we can get this guy right at 90, and that'll be the trick. Oh wow, look at that. We basically, Oh, I thought we were connecting this other probe. we're almost there. If we can get this at a straight 90. Yeah, that's what I'm talking about right there. If we just look at this, we do have the maneuver node planned, so this guy's just doing his adjustment. We want this to be as close as possible. And to be fair, it is a little bit difficult because we're off by so much. But you can see we've already got this first amount of data, and I will run this just for a couple of minutes, just to show that we can in fact get science out of it. Hey, look at that inclination. That inclination is something else. Okay. Let's try to keep this from vibrating. That node is in about 3 minutes. So I'm going to get ready for it. This is where RCS, even though we have it, would come in handy. I just didn't put it on any of these probes. Oh, well, damn, we gotta go like that. I think that's closer than what we had. That's a fairly tight orbit. I'm happy with it. Anyway, if we run this for a bit, I think if we get up to 30%, yeah, it is skipping a few things. We're not too high, I don't think. I just think it's, yeah, we'll run it. Because we can't really go faster than 1,000. But basically, as we deal with this, what we can do is we can right-click on this dude here and tell it to analyze data. And we've now got science we can send. And the more we collect, up to 95%, I believe, the more we collect, the more science we can transmit. And so we're already pretty close. We're probably going to be able to send 5 or 6 at this point. We're just filling in these gaps. Other good things about this mod, the ScanSat mod anyhow, is that when we get close enough, as long as we just get that up to that 95% science real quick. There we go. Another good thing about it is that as long as we put one of these on it, that would be the map track, we can actually have anybody use it. And then not only that, oh nice, let's see if there's, anything else we can send. Yeah, we can get a lot of science out of this. I believe that is going to be it. Point 2 maybe. I mean, it's practically free. I bet, our energy consumption actually isn't that bad. But, yeah, you can also, we can put better satellites up here eventually and collect more science. That would include even biome data. So we'll go back for the moment, and let's just see. I don't believe we can afford anything with that, but with that having been said, I think our next goal will probably be a space station. Work on that a little bit. Maybe begin getting some stuff out to Minmus as well. But until that time, this is Thylord Root, and I will see you later.